Hello students, so today I am going to start a new chapter, that is chapter number 5, that is the laws of motion chapter I am going to discuss. Okay, so the laws of motion if I discuss. So regarding the laws of motion, you have already seen in the class 9 about the laws of motion. So first part that is related with the laws of motion, we have the rest and the motion. So how will you come to know that the object is in rest or the object is in motion? That depends on the observer. Okay, that depends on the observer. Like suppose if I consider there are two buses. Okay, suppose if I consider this is one bus, this is one bus. Okay, these are the two buses. Both buses are moving along the same straight line. Now if you consider both the buses moving in the same straight line with the same speed, okay, moving with the same speed. If it moves with the same speed, the observer, okay, if the observer sees from here to this sitting in the bus, okay, so he will be seeing that the person sitting in this bus, he will be seeing that the person is at rest. Similarly, if a person from this one, if it sees to this bus, he will be seeing that the person is at rest. So it depends from where the observer is seeing the object. Okay, so depending on the different types of condition, we can determine what is an object is in rest or whether it is in motion. But the example that I have taken, both were in uniform motion. Okay, so that we have already done. This chapter, what we are going to discuss is we are going to discuss, as you can see the topic, it is about the introduction of the laws of motion and the inertia. Now, what is the laws of motion? There are the three laws of motion, but before the Newton laws of motion came into impact, there were some observations that were done by certain philosophers and also by scientists. Okay, the first philosopher was the Aristotle. Aristotle gave a concept of the first law of motion. From there the concept of inertia came. Okay, that was the first step. So according to the Aristotle, he told that if I throw an object to the ground, the object will regularly move to the ground. If you don't stop the ball, it will be continuously moving to the ground. Okay, but if you consider, that concept is totally not true. If you throw an object to the ground, after some time it will obviously stop. Why? Because of a certain force which we call as a frictional force. Okay, so that concept was not given by the Aristotle, because Aristotle was a Greek philosopher. Okay, he was not a physicist. So that concept was called as the Aristotle's fallacy method. The next we have the Galileo Galilei's experiment. Okay, so the Galileo Galilei's experiment, if I show here, let me show the Galileo Galilei experiment. So the Galileo Galilei's experiment was based on inclined plane. Okay, so there were two inclined planes, like this is one inclined plane, this is another one inclined plane. Okay, there are two inclined planes. This is having a height h, this is also having a height h. Okay, both are having the same height h. Okay, now suppose according to the Galilei, if he throws or if he tries to move a ball from the top of the first inclined plane, if it moves towards a downwards direction, that ball will be reaching to the inclined plane, that is the second inclined plane. Again, it will be stopping at the same height, according to the Galileo. The second observation what he has done, he has reduced this inclined plane angle, that is the angle of inclination. He has reduced a little bit. Okay, he has reduced a little bit the angle of inclination, but this is not changed. So when the ball is being released, he has seen that suppose the height of this inclined plane, here it is a height h. So this ball will be reaching up till this point. It will be not going to the top of the inclined plane. Why? Because it is released from height h, so it will be stopping at a height h only. Next, what he has done, he has reduced the inclined angle angle of inclination to 0 degree, totally plane. He has seen that the object that was moving from the first inclined plane, it is moving continuously in this inclined plane. Okay, it will be continuously moving in this inclined plane. So this object can be stopped only if you apply a force from outside. So from that concept, the inertia concept came into existence. Because the concept of inertia, as you have already got in 9, inertia of rest and inertia of motion. An object at rest will remain at rest, an object in motion will remain in motion until and unless you apply a force from outside. So this object will continuously move, but it is not true, okay? It is not true. We cannot make a frictionless surface. Physically, it is not true. Okay, we cannot make a frictionless surface. After some time, it will obviously stop. Okay, but according to the concept of the inertia, if we want to stop this object, we have to apply a force from outside. So, if I give an example of the inertia of rest and the inertia of motion, there is one more inertia, there is the inertia of direction. Inertia of rest is like, for the example, suppose, the perfect example you have already got is about the bus. When suppose your bus is at rest, okay, the bus is at rest, like suppose I am sitting in a bus is at rest, suppose suddenly a bus starts, okay, suppose suddenly a bus starts, initially your whole body was at rest, the whole body was at rest, the lower body, the upper part of the body was at rest. So when the bus suddenly moves, this body, okay, this body, the upper part of the body, it suddenly moves backward, okay, it suddenly moves backward. Why? Because the lower part of the body still tries to remain in a state of rest. This is an example of inertia of rest. Similarly, you are at rest, okay, and suppose your bus is moving, and you are sitting inside a bus. Suppose the bus suddenly applies a brake. So what will happen? Your whole body initially was in motion. When a brake is being applied, so what will happen? The lower part of the body will still tries to remain in a state of motion. This part, what will happen? You will come forward. Why? Because of the inertia of motion. The lower part will come to rest, but this part will try to remain in a state of motion. Okay, so this is called as the inertia of motion. And if you consider inertia of direction, like suppose we have a circular road. Okay, we have a circular road and a bus is moving. Suppose it takes a certain turn and we have a luggage above it and that luggage is being not tied. ठीक है, वहाँ पे मैंने luggage को tie नहीं किया. अगर luggage को tie नहीं किया होगा, अगर suddenly एक circular turn ले लेगा, तो क्या होगा? The object that was above the bus, that object will be falling towards the forward direction. Why? Because of the inertia of direction. Okay, so this is called as the inertia of rest, inertia of motion, and the inertia of direction. Okay, these are the three types of inertia. And inertia is also called as a resistance of the body. Okay, resistance of the body. So more, if you increase the mass, the more will be your inertia. Inertia is directly proportional to your mass. More will be the mass, more will be the inertia. Like for example, if I consider a 5 kg object and if I consider 10 kg object, the 5 kg object and the 10 kg object, which one will be having more inertia? Obviously, the body having the higher mass, that is a 10 kg object. Okay, so this is what is the concept behind the inertia. So based on the Galileo Galilei, the law of inertia came, that is the first law of motion, the Newton's first law of motion. Okay, then we have the Newton's second law. The Newton's second law of motion states that the force is directly proportional to the rate of change of momentum. Okay, rate of change of momentum, or force is directly proportional to the rate of change of momentum. Okay, it is dp by dt. So what is the meaning of this? The term P, we call that as a linear momentum. What is the meaning of the momentum? It is the amount of motion contained in a body. Amount of motion contained in a body. So if I consider, as for example, we have a 5 kg object and we have a 10 kg object. Both are moving with initial velocity u and both are moving with the same velocity. Suppose if I tell you to stop these two objects, so which object will be requiring more amount of force to stop? Obviously the 10 kg. Why? Because the amount of motion contained in the 10 kg is more than that of the 5 kg. So we can tell that the momentum, since it is related to the amount of motion, it is directly proportional to your mass. The same way, if I consider that the first object is 5, the second object is also made up of 5 kg. Now, if it is moving with u1, since it is moving with u2, and if it is considered that u1 is greater than u2, now which one will be requiring more amount of force to stop? Obviously the object which is having the more amount of speed or velocity, which is having the 5 kg object, because u1 is greater than u2. So you will be needing more amount of force to stop this object. So we can write that P is directly proportional to your velocity, or we can write as, generally we can write as V. So if I combine these two, so P will be equals to M into V. This is the formula for the momentum. So if I place in the Newton's second law of motion, so F is equals to K d M V by dt. Why K is there? Because we have the break the proportionality constant. F is equals to K dmv by dt. Now, as I have already taught you about the derivation, okay, about the differentiation we have already done. So here your mass is constant and velocity is depending on time. Okay, put m outside. So K into m outside. So left out will be dv by dt. So the rate of change of velocity divided by time, we call that as a acceleration. K m into a. Okay, if suppose k is equals to 1, so what we can write? If k is equals to 1, okay, if k equals to 1, then what will you get? F is equals to ma. So this is the mathematical form of Newton's second law of motion. Force is equals to mass into acceleration. The third law, everyone knows, it is in everyone's mouth, that every action has equal and opposite reaction. That everyone knows. Okay, so we'll be discussing some of the applications related with the first law, second law and the third law in the next class. So thank you for today.